Here at ITI, and welcome to this month's edition of the Showcase webinar series. Today we got a great presentation for you. It's titled Crane and Rigging Brain Teasers. We're going to roll out a brand new format today, so I'm going to go through the logistics and the ins and outs of that, just so everybody's on the same page before I turn things over to Mike. The format's going to be a lot of fun, really. It's going to be a quiz that corresponds with the presentation that you see on the screen. In addition to being really a lot of fun, it's going to be really useful on your end. It'll help you identify any potential knowledge gaps that you have when it comes to crane and rigging activities. So it is possible to have some fun and do something productive at the same time. Bear with me while I touch on just a couple housekeeping items, and then I'm going to show you how to best set up your screen for the quiz. So who is ITI? ITI, we're a world leader in crane and rigging training and consulting. And I want to emphasize world, and as you can see on the map there, we're proud to work all over the world. Our trainers have been on every continent, conducting training, doing consulting work, audits, things like that. So it's really our mission to be regarded as the world's foremost provider of educational and technical services for everybody who conducts crane, rigging, and load handling activities. So we try to accomplish our mission every single day through our training courses at both client locations and then our 3 North American training centers. One of the really core values that it's near and dear to us is innovation. We just take great pride in finding solutions to every challenge brought to us by clients, and they really do range from, anything you can think of, we've heard questions on. So it's a testament to our staff that they can adapt and really find solutions to almost anything out there. Another way we try to fulfill our mission is by providing just so many resources to anybody in the industry. These are all free resources that can be found on our website. You can easily spend hours just looking around at everything. Everything from ASME interpretations. There's 3 different blogs with different themes. We have info kits, white papers, ebooks, videos that are entertaining and educational. There's a ton in there. So if you have downtime or if you're looking for something, if you have a question about something, this is a great place to start. I touched a bit on this in my intro last month, but if you can't tell, I'm just really excited for the Fundamentals of Rigging Engineering program that we're launching in January. I know this term gets thrown out there a lot, but it's true. We have a dream team of developers and instructors. They're working on the course content right now. They're in peer review mode, sending stuff back and forth. So many ideas are flowing. It's really cool, and so excited. 2015 is going to go off to a great start with this course being available to everybody. We have an ebook on the course that we made that gets into a lot more in-depth of each individual course of the program. I recommend downloading that. Again, it's free. Just head to riggingengineering.com. It's on your screen there. This program's amazing. I can't say enough about it. I know continuing education is huge in all fields, really, but especially in engineering and cranes and rigging and lifting. So definitely, this is a great opportunity to do that. So Mike Parnell, ITI President and Technical Director, he's going to lead us through our exercise today. Many of you on the line are familiar with Mike's work in the industry. I want to point out that he volunteers his time and serves on 2 ASME committees. He's the Vice Chair of the ASME B30 Main Committee, which sets the standards in the U.S. for cranes and rigging activities, and then the new ASME P30 Committee, which sets standards for lift planning. Okay, so here's where the fun begins. On the screen, you can see a URL that will launch your crane and rigging brain teaser quiz. I also sent out a link into the chat box, and that's the easiest way to launch the quiz. So if you guys want to click on that link right now, and I have a screenshot that I pulled up. This highlighted portion in the bottom right of your screen, if you click on that link, and I'm actually going to resend it out just in case somebody missed it. So I just sent it again, but if you click that, it'll launch in your browser automatically. I'm going to do it myself here and launch my quiz. So we're on the first question there, you can see on my screen. I'm going to minimize it down. And have both be available for viewing, both the presentation and the quiz. And you can resize according to whatever you're comfortable with. So I'm going to do a little bit more than a quarter page there, and then I have my presentation file as well. So just to format a little bit, there are going to be 30 questions total. Depending on the difficulty of the question, you're going to have between 10 and 20 seconds to submit your answer on the quiz. It'll usually be around 12 seconds. Once time is up, Mike's going to provide a short explanation on the answer. Then we'll move on to the next brain teaser. So as everybody can see my screen, that's what I recommend, the best practice there. If you do have any questions, please utilize the chat box on the webinar window. If you have any technical questions, I'll do my best to get you an answer in the chat box there. So I want to point out one more thing. I'm sorry, let me back up for 1 second. So I know I can't see any of your screens, so everybody's kind of on the honor system a bit, and the quiz is going to be in a different window. Just everybody relax. No one else will see your answers. Your quiz results will be sent to you via email individually, so you can see how you did and check your work against the presentation file that will be posted after. Really test yourself is what I want to say. Try to keep up with Mike's pace, and if you don't know something 100%, I mean, try to problem solve, use what you do know, and give it your most educated guess. This is really, again, it's fun. The information's not going to be made public at all, so yeah, it should be a good time. Alrighty, so if everyone's ready, I'm going to toss the screen over to Mike, and I think he's going to be loaded up right to the first question. So,
okay.
All right, Mike, we can see your screen.
All right, excellent. Hey, welcome everybody. We're glad to have you with us. This is May 2014, and we're just on the doorstep of summer, and we're going to be looking forward to some lots of projects outside, both at work and hopefully with your families. You guys have a great time with your families this summer. To kick that off, we identified a series of questions that we have built into something of a rigging Jeopardy type layout. And it's a quiz format, but it's also a learning activity. So that's the purpose today. And John has done a great job helping get us all on the same page. Hopefully you've got your SurveyMonkey set up. And as we go through the questions, I'm going to also do a little step aside once in a while to help explain different elements that might be appropriate for our own organization and activities in our sites or locations, how these things apply. Most of these things will come at us from a bit of the ASME perspective and a little bit of OSHA, and then good or best practices. So first question is, which of the following is not a proper method for determining weight of an object to be lifted? Jonah, we'll start the clock. Check the maintenance manual, calculate the weight, check the nameplate data, or D, guess the weight. So which one is not a good method for determining weight? And we're probably down to our time. So make your selection in your survey box for item number 1. And then let me put we'll get the answers going right here then. So the answer to this one, of course, is guess the weight. And that would not be a good approach. There are a number of workshops and things that can be done to help calculate the weight based on volume. Height, width, and length times, say, 500 pounds is a common rule that we use. We may take a gearbox or an electric motor, large motor, and get the weight by height, width, and length. Let's just say it's 2 times 2 times 3, it's a lot of proportion there, but times 500, which is about the weight of a cubic foot of steel, times the density factor. In this case, we're going to use 30% as solid mass versus air. So 2 times 2 is 4, times 3 is 12, times 500, and that's going to give us 6,000 total times 30%, and that motor will end up to be about 1,800 pounds, more or less. And so it gets us close. And that's a formula that comes off of one of our rigging cards and helps get the idea across that there is a way, even if it's not a solid block of this or a plate of that, there are different ways to calculate or estimate load's weight. And of course, the density factor is the secret based on what we basically understand about the load. Maintenance manuals have weights in them from time to time for different components, and then the data plate, of course, would be another good option. Let's go to the second one. And here's the question: what type of damage is not likely to occur with wire rope slings? And we'll start the clock, Jonah. And ultraviolet ray degradation, broken wires, corrosion, or severe metal loss. So take a look at your options there. What's not likely to happen with wire rope slings? Give you a few extra seconds. And okay, good. We should be timed out there. And of course, the answer is going to be UV degradation, ultraviolet, which would affect some natural materials like cotton, and certainly in our world, we have nylon flat web slings, and we have polyester and flat web slings, and those are easily attacked by UV, but not wire rope. So broken wires can affect wire rope damage and corrosion and severe metal loss. So A would have been our answer there. So let's go to the next one. When lifting a uniform load of 2,000 pounds with 2 slings rigged at 60 degrees from the horizontal plane, approximately how much or how many pounds of tension are on each leg? So if we just have a load down here, and we'll hold the clock just for a second, Jonah, and we're going to rig this up, and the assumption is, let's say that's 10 foot from lifting lug to lifting lug, and we're going to rig this up at 60 degrees. That's that angle from the horizontal right there. What is the approximate load weight? That's 2,000 pounds. So the question is then, well, what's the vertical load if the CG is centered? So we're going to start with 1,000 pounds of vertical load. And it becomes something greater when we ask that sling to work at this angle. So the force is higher. And I did, so let's take a look then at our answer. Is it 1,000 pounds, 1155, 2,000, or 11,490? So let's go ahead and fill in our answer. All right, and I'll put the answer up on the screen. And that answer is 1155. And I'm going to take you back to that drawing real quick. I'm going to put up, so this is something we all probably want to put a little bit to memory. This is a Master Rigger's reference card, and there are 3 significant angles that we work at besides pure vertical. And we know about 90, of course. That's not one of the 3. The other ones are 60 from rigging charts, 45 degrees, and 30 degrees. And what we want to do is take a look and see what is the load factor or sling leg multiplier created at 60, 45, and 30. And right in here we'll see a length of 1.155 and a height of 1. So we'll go back to our little challenge there, and we just take 1.155 divided by 1, which is still 1.155, times a share of load of 1,000 pounds, and we're going to find out that that anticipated tension will be about 1,155 pounds. Hopefully that's what most of us got on our solution. That is our solution for 3. So you want to kind of and let's go back to our card. Notice that there's our multiplier for 60. 1.414 is for 45 degrees, and then a load factor of 2 for the 30 degree from horizontal. So it just helps us, if you have those three kind of blazed to our memory, that helps us quickly when we need to understand how to arrive at single leg loading for multi-leg assembly. Okay, let's go to our next question here. And the normal design factor for a 6-strand wire rope used as a hoist rope on a mobile crane is, and we'll start the clock, Jonah. All right, so it's a 6-strand rope. It might be 6 by 26 Orrington seal. So 6-strand rope used for a hoist rope for a mobile crane. And the options are A is 2.5 to 1, 3 to 1, 3.5 to 1, and 5 to 1. So if you've got your selection made, that's the design factor for that rope that's right over here in the photo for that whip line. So let's come down and we'll go to our solution. Time's up for everybody. And the normal design factor for in the U.S. is 3.5 to 1. So if we have a wire rope that has a minimum brake force, let's just say of 100,000 pounds, the design factors apply 3.5 to 1, so that single part line is 35,000, and there are at times we may make in certain applications may make an adjustment for the wedge socket. In certain applications, the crane manufacturer may pull that down to, he may say it's 32 based on the available ropes in that neighborhood, and give us the real working load limit or allowable line pull for that crane, but that would be the maximum allowable in most applications. Excellent. So that answers 3.5 to 1. All right, let's go to the next one. Question 5, tube blocking with a mobile crane can occur, and tube blocking is when I'll just put a headache ball here, and we'll wedge socket, and we'll run that right up into the crane boom, right up over the top, and there's a small weight hanging down there, hopefully, and it's all competent, capable, and it's able to cut the power off to the hoist. But tube blocking is running that ball or block up into the crown block. That's why there's 2 blocks, traveling block and crown block. And so when can that occur? And the question gets to be, can it occur when we're retracting the boom on a hydraulic crane like that, when we're extending, when we're booming up, or none of the above? Tube blocking with a mobile crane can occur while A, B, C, or D. Everybody take a quick look. Let's go ahead and fill in our answer. And our solution there for number 5 is extending the boom. So as we extend the boom out, we're chewing up hoist line, and that can certainly raise the headache ball or block in the case. And so as we extend out, that hoist line is being chewed up. Even though we may not be activating the hoist lever, we're chewing up hoist rope, and we can tube block it inadvertently. It would not be retracting, booming up, or none of the above. So item B, or answer B, is our solution there. Let's go to the next one. Excellent. How much tension is added to a sling if used at a 30-degree angle from the horizontal plane? You remember we talked a minute ago about understanding the load factor created when the sling is working at an angle less than 90 degrees. And so is the additional tension, is it 15% more, 40% more, 100% more, or 25% more? Give you just a few seconds here. Okay, time's up. Hopefully you got your answers in. So let's go to the solution there. And that is 100% more tension. And so that is, let's go back to that master rigger card just for a second. Notice that we have at 30 degrees, right down here, we're going to double the tension. 2 divided by 1 is then applied to the vertical load on the pick point, and so it will be doubling 2 times the share of load weight for that sling, and so in effect it's 100% in addition to net load or share of load. Okay. All right. So let's go back to our quiz there. Excellent. How's everybody doing? I hope we're having fun and getting some of the solutions that we're looking for and getting some good scores. Let's go to the next question. Question 7. Compared to a web sling, a chain sling is well suited to lift what kind of loads? Compared to a web sling. So really the question is about a chain sling is well suited to lift slippery loads, 500 degree Fahrenheit, delicate or large loads. So take your options there, A, B, C, or D. Let's put in the choice in your survey quiz and see what we get. So time's up. Okay, let's go to our solution down here. And the solution right there is going to be 500 degrees based on those 4 options. Most of us know when we use chain slings, they and I'll just work in Fahrenheit for a minute, minus 40 Fahrenheit, and then up to about 400 degrees Fahrenheit. And then from 400 degrees to 1,000 degrees, there are temporary reductions and in some cases permanent reductions, but they top out basically at 1,000 degrees for most chain sling manufacturers. So we have free reign to work in that minus 40 to plus 400 range. Between the 400 and 1,000, we have some limits, but certainly they're still able to work, especially in furnace areas and steel mills and all kinds of hot places. Chain slings would definitely be our sling of choice. So when we start to get to those high ends, we probably want to be thinking about chain or wire rope particularly. All right. Here's a good one on overhead cranes. Let's take a look. Wire ropes on overhead crane and overhead and gantry cranes should be replaced when the inspector finds how many randomly broken wires in one rope lay or how many broken wires in a strand in one rope lay. In our options, take a look. Let's figure out which we want to mark here. Option A is 20 and 14, 20 in a lay and 14 in a strand in a lay, 15 and 8, 12 and 4, or 9 and 7. And this is based on, and this is ASME B30.2, overhead cranes and gantry cranes. So most of us should have an answer by now, and we'll take a look and we'll see, okay, 12 and 4, 12 broken wires. 12 broken wires in a length of lay, or 4 in a strand in one length of lay or rope lay. We have a similar question, I think, coming up for mobile cranes, and once we get there, I'll help explain why the numbers do vary or are different. Excellent. Let's go to the next question. Question 9: the point of an object about which all parts are balanced and its mass is concentrated is its what? Is it load center, midweight, center of gravity, center line? It's the point about which all parts are balanced and mass is concentrated. So we've got A, B, C, or D. Jonah will go a few more seconds here. Okay. All right. Okay, hopefully you've got our Survey Monkey clicked in there for question 9. And let's pop up our solution here, center of gravity. And that really is the definition, one of the working definitions for CG, or center of gravity, that we use in our industry, is a point about which the whole weight is concentrated, or mass. And so CG, you'll often hear that phrase or see that in writing. Center of gravity is pretty universal, and it should be accounted for. You know, it's one of the 3 axioms of rigging, which is what's the load weight, where's the CG, and what is the rigging method. Those are the 3 steps when we start in on deciding how to get a load moved. What's it weigh? Where's the CG? Because that's going to make a difference in how much load we have on any piece of rigging, whether it's a jack or a roller or slings or shackles. And then what is our rigging method? How are we going to control and move and handle the load? Okay, very good. Let's go to question 10. And it says, when a load or stress breaks a piece of rigging equipment, that piece has reached its what? And this is a little bit of layman's terms. There's a dozen ways to try to say this, but for our purposes here, just simple terms. And assume, it's a new piece of gear. So what's the term or phrase for that? Maximum safety limit, minimum rated capacity, working load limit, and braking strength. Let's put in for question 10, let's put in our proposed solution or best option, A, B, C, or D. Ready for that? Okay, we're going to go ahead and put the answer up here. And that answer in our term or phrase is going to be braking strength. And there are other terms out there today. It may be minimum brake force sometimes, and that's really the target point at which that object will fail. It's typically yield is less than minimum brake force. Yield is deformation. So we're maybe buckling it partially up. It's a permanent type of damage is deformation, so it's not just deflection. Certainly would not be working load limit. We'll take a line through that. And so on a load chart or pull chart for a test machine, we may have a sample piece of wire rope that would have a minimum braking strength or minimum braking force at 100,000, and our working load limit or rated capacity for a sling may be in that 20% range. And that's, let's just say that's after fabrication and so on, and after all the other deductions are made. So our solution here and just of the 4 options available to us is braking strength. All right, let's take a look at question 11. What hand signal shall a crane operator take from anyone? And there are, various views of this, but that's okay. Let's take a look. Is it hoist, stop, lower, or travel? And the key word here is anyone. Hoist, stop, lower, or travel. Which one is he obligated to respond to? And that should be pretty easy. I think most of us are been in the business long enough. And then we'll click on 11's answer. Hopefully you got your answers already put in. So let's take a look, and it is a stop signal, and that's really per OSHA and ASME. And some folks may say, you may have a spotter or someone else on the team, the tagline guy that sees something nobody else sees. We're about to crash into something, so he can give a stop signal, get it to the operator and signaler, and other folks may decide, well, we're going to call it an emergency stop, and that's okay too. It gets us to the same place. Emergency stop just requires, with mobile cranes, requires 2 hands instead of 1 hand, flat palm to the ground, and all hand is flat, waving back and forth, chest out, chest out. So that is the official response for that question is the stop signal. All right, let's go to question 12. When using one chain fall or one come along in a 4-part pick, how much of the load should each part or leg be able to support? So we may have a 4-corner load here that we have lifting lugs on all corners, and we're going to use 3 slings and come down to 3 corners, and then we'll use a chain fall hooked right in. Let me get that right here, and then rig down, and that chain fall is down here for trying to attempt to equalize the loading to all 3 plus their horizontal force issue. So that's really the question. You got a 4-leg assembly. One of the 4 legs is a chain fall or come along, and when we do that, how much of the load should we anticipate could be applied to each part or leg. This is a little bit of a tricky one, and so take a look and consider well. So the options are 25% of the load to each leg, and we then account for angle, 50%, 75%, or 100%. And this is one of those best practices. We won't find this in OSHA particularly or ASME. This is a practices item. Let's take a look. Hopefully everybody's got their answer put in. And the answer for 12, our recommendation from ITI is 50%. It would be easy, and I'm going to just draw out these 4 legs here for a second. I'll hook that up and run this down, and that's tight. And the brother across to it is tight for that sling, and these other opposing slings may be somewhat slack. And so it would be easy to end up with this one's in tension, this one's in tension. These are all, the other 2 are kind of on vacation. So really you ought to rig big enough. That means, and really all rigging, all sling shackles and that chain fall should be able to take 50% of the load, and what we've left out of this is plus the effect of angle, and it could be times 1.155 for 60 degrees or times 1.414 for 45 degrees and so on. So we didn't put that part in, but just to understand, we got to rig big enough to anticipate, because it won't all be equally balanced. If we can move that chain hoist and adjust, we're able to either tighten or loosen that, and at some magic point right there, you might be perfectly equally loaded, but 99% of the other time, it's going to be misloaded, and we're going to have diagonal loading from this corner to that corner. So that diagonal loading really on a 4-point is going to mean 2 legs are carrying it, 2 legs are balancing it, and our rigging needs to be able to sustain that. Okay? All right, excellent. All right, so we told you there's going to be some educational parts to this, and that some of us live and die by the 2 legs carry, 2 legs balance concept. But I want us to all realize that most of the time we're going to have misloading across there, even though that chain fall is doing its best. And that can certainly happen without using a chain fall, just grabbing 4 slings off the rack and trying to make a 4-leg pick. That's not a pre-manufactured assembly. So this best practice still plays out. All right, very good. 13. When using nylon slings, all sharp corners of the load should be padded to prevent. And that statement is pretty effective, whether it's a sharp corner, and that's all a bit relative to all of us in the industry. But let's take a look at this. When nylon slings are used, sharp corners of the load should be padded to prevent what? The slippage of the load, the rotation of the load, damage to the sling, rotation of the sling. Okay, let's make sure and click in our best option, A, B, or C, or D on our SurveyMonkey answer there. All right, we're going to go forward then. We'll put the answer up here, and the answer would be, really, it's not so much about the load, it's about damage to the sling. Out of all of the accidents we've investigated, 1/2 were crane and rigging procedures, and 1/2 were sling, I'm going to call sling failures, or sling-related accidents. Out of that half, 87% that we've investigated are with synthetic rigging. And I got to tell you that we all use them, and they're great tools, but it is that we have to step up and provide the necessary protection. I think if we have one thing we want to do in the next decade here is enhance our sling protection and make sure it's robust enough to take the PSI in moving a load. We are, I know this is just a weird aside here, but we are currently in our 4th, and I'm just going to draw a really, ugly looking box base here for a crane, but it is the boom was removed from this crane, and It's a multi-axle, multi-tire unit. They rigged from the outriggers that were extended to put this up onto a ship. And so you can see the rigging points were up here, and this one come around. All went up to spreader bars for a 2-crane pick. So crane 1 and crane 2, and to pick the crane base and the superstructure without counterweight, without boom, and all of a sudden the PSI right here is just incredible. And all 4 cases happen almost identical. I mean, it's just like history continues to repeat itself. The PSI, we're looking at about 7,500 pounds per square inch of load across the synthetic slings. And that amount of pressure, just a little bit of rubber belting wrapped around there to just look to appear to be sufficient protection. The loading across the width of that sling at 7,500 pounds per inch, sheared through the belting, cut the slings, drop the crane. So and it happens. All the rigging stays on the hook. The crane's upside down. All crash and burn, and it's just it's a devastating occurrence, and it's something easy to protect against. If you think about that, that's like like a 3/4 ton truck bearing at every inch of width. And so if we use a say a flat web sling, maybe 6 inches wide or so, every inch of that, in just simple terms, has that amount of pressure on it. So it's a 3/4 ton truck, actually full weight, bearing against that corner, against this corner, against that edge, that point, and continue on. And we just have box beam inside right here, just steel plate. And we're just begging for a wreck. The protection has to be robust enough to withstand that kind of pressure. So sling protection is really, really important. Let's go to question 14. Go ahead.
If I could jump in real quick, Mike, we could talk about this issue all day, and many of you are aware of this, but we do have a sling protection ebook available in the resources tab that I mentioned in the beginning. That goes through a couple case studies. It has examples, use cases, and again, that's free. So if you want to investigate that further, that's available to everyone.
Good, Jonah. Thank you for that. I would that kind of dropped out of my mind there for a minute. Yeah, we do have some good case studies. So sling protection is probably a biggest thing. If we can do any benefit to our industry and to those that are work with us and for us, I think that's probably our #1 big thing we want to step up. And there are some very robust, good product items out there that are commercially available, and we should be investigating those heartily. So let's go to question 14. Thanks, Jonah, for that. While inspecting shackles prior to use, any cracks should be repaired. Bound shackle pins should be tightened. Irregular shaped shackles should be bent back into shape, or shackles with damaged threads should not be used. So that comes out of our ASME document first. ASME B30.26 is rigging hardware. Good instruction there, and OSHA has started to address that as well. So pick A, B, C, or D. Cracks should be repaired. Bound pins should be tightened. Irregular shaped shackles, which means they're deformed, should be bent back into shape. Or shackles with damaged threads should not be used. And let's go to our solution down here. Everybody's got your Survey Monkey click there. So let's find our solution, and that solution is shackles with damaged threads should not be used. And obviously any deformation is out. If we got a bound pin, we got a problem. We probably have some deformation occurring or damaged threads or alignment issues, and cracks. Definitely any cracks in a shackle, just we can't be welding or trying to repair a shackle. If you have a high tonnage capacity shackle, 100-ton, 200-ton, 300-ton shackle, you may send that back to the manufacturer and see if they can do anything with it. Otherwise, it may be toast. So we want to make sure out of the solution options here, D is our best answer. So let's go to the next one. Item 15 is the rated load of a rigging block is based on what? The rated load of a rigging block, and let me put up a, rigging block has a sheave and has a shell. We'll put a shell on this thing. And then it has a shackle, bail, or hook, and we'll just put a shackle up there. So this block is rated on, and let's draw in a couple of lines here. And let's say this side's going to the winch, and this side is going to the load. Okay. All right. So the question is, rated load of a rigging block is based on what? Is it pounds of pull on the winch line, primary load fitting, which is at the top, pounds of pull on the load side of the sheave, or the sheave diameter? Which one of those four do we think dictates or constitutes the rated load of the rigging block? A, B, C, or D? And we're going to pull up our solution here. Make sure you got your boxes checked. Okay, and the answer is primary load fitting. And I'll go back to our drawing there and identify that, the whys and what fors of that. We take a look and we put a load value down here of, sorry about that, 2,000 pounds. 2,000 pounds on the load side and 2,000 pounds, and we'll just put a plus there on the winch side because to overcome friction. And so we've got about 4,000 plus total on that. Really, it's on the primary load fitting, which is this shackle right here. So in this case, 2 is 4,000. This would have to be at least a 2-ton block. And the 2-ton block, that rating right there, that 4,000 pounds is 2 short tons, and that is that shackle capacity, and that is the capability of that entire block. That does not mean we can actually pull 4,000 pounds on the winch because we've got a 4,000 pound load. That would overload that whole block and not be an appropriate choice. So really, worst case and best option for us is to review, well, what's my load going to give for resistance? And we'll take that number 2,000 times 2, and that's the size of block we should be using for that application in most cases. I mean, it's a worst case scenario, and we would rig up accordingly. Okay. All right, excellent. So there's our answer is primary load fitting, which could be a hook, shackle, or bail of some type coming out of the top of that rigging block. Let's go to the next question. Question 16, as the sling angle gets closer to the vertical, the amount of stress on the sling does what? And so a visual for that, let's think about this. I'll just draw a 2-point pick here. And so instead of the rigging at this angle, and the question is, it gets closer to the vertical, so that means it goes up. When we rig with longer slings, the amount of stress on the sling does what? Increases, decreases, stays the same, or exceeds the safety factor. Which one of those is the best answer? Give you a few seconds. Okay, time's up. We got our box checked in our survey. And what will happen is the tension basically will decrease as the angle from the horizontal increases. As the sling gets longer, the tension goes down in the sling as applied. Okay? And we know that the opposite of that, so we'll go back to that picture and we'll know that it decreases here, and if the angle got really flat, oh boy, that's bad. And we come down, that loading will increase in the sling leg as a relationship of the length of the sling and the height off the load. Okay, excellent. Let's go to our next one. Let's go back and make sure we don't double jump here. All right, let's go to question 17. The center of gravity is approximately how far from the head end? So let's take a look at this guy. This end lifted at these two bearing points. Lift that up 6 or 8 inches and it weighs 22,000 pounds. At the far end, right at that, there's a block bearing point right there, and that weighs 34,000 pounds. The span is 20 feet between those two bearing points. So how far from the head end is the approximate center of gravity? So the span's 20 feet. So the question options are, is it 6.8 feet from the head end, 10.2 feet, 12.2 feet, or 14.6 feet? I'm going to give you a few seconds here to consider those options there. And we're going to put our solution up here. All right, let's take a look. And our solution is, and let's go, hopefully everybody's got their boxes checked. It's all on the honor system. We're all Boy Scouts here. So, all right, and the answer is 12.2 feet. Sorry about that. We'll lighten that up. And let's go back to our drawing, or we can just use this one right here. So an easy way to think about that quickly is, if I'll leave off the zeros, but if 22 plus 34 equals 56, let's just divide all the parts by the whole. And 22 divided by 56 is 0.39. And 34 divided by 56 is 0.61 equals 100%. Okay. All right, 34% or 39% of the weight means we're going to go, then the inverse of that is 61% of the distance. Okay, so we're going to go 61% of the distance from the head end, and 0.61 times 20-foot span. Let's punch that in real quick. And that is 12.2 feet. So right down here is the approximate CG. So we're just using that value, 34,000, this value, 22,000, to help figure out where's the center of gravity. We likely will need that center of gravity if we're going to load this out on the truck. We need to know where that center of gravity is for axle loading so we can get it properly placed on the truck for the rear axles and the drivers. Okay. So quick method, add the first weight to the second weight, get the total, divide all parts by the whole, we get our percentages. Now what happens is, basically that percentage works this direction, this percentage, and we'll call it 61, works this direction for distance. Okay. All right. Very good. Excellent. Hope everybody got that one right. That was a little tough one, but that's part of what we're doing here. Question 18, what type of rigging would be preferred for handling a load in a 300-degree Fahrenheit temperature environment? And the options are nylon, slings, wire rope slings, chain slings, or B and C. Go ahead and hit the button on your Survey Monkey for your best option. Give you a few seconds. Nylon slings, wire rope slings, chain slings, or both wire rope and chain slings. And let's go to our solutions down here. And there we go. And the answer there is B and C, which is wire rope sling and a chain sling. Wire rope slings can work up to 400 degrees Fahrenheit. And if we go above that, we need the manufacturer's consent. And so we're at 300 degrees right here, and so wire rope will work in that range as with an independent wire rope core, not a poly fiber core. And then a chain sling, as we've already discussed, will work there in that degree range. We said minus 40 to plus 400 is a simple working range without any reduction. So, all right, excellent. Let's go to next question is 19. All right, let's think about this just for a minute. Considering a mobile crane, the weight of the suspended load block and rigging is 45,000 pounds. So I'm just going to put up a little bit of a, we got a multi-part line there. It's 6 parts a line. That's part of the question. Put a load block, hook, rigging, and so on. So everything combined, that entire menagerie right there cost us 45,687 pounds. We want to, we're going to reeve the block up in 6 parts a line. So there are 6 parts right here of hoist line reeved into that block, be it at least a 3-shiv block. So we have 6 parts a line. The question is, what would be the approximate lead line stress on the main hoist line? And the lead line stress is that 6th part of line coming back down to the winch or drum. Okay, so how much load is on that lead line or first line coming off the drum? And that in the industry, it's called lead line stress. And we often calculate that up based on shear friction and parts of the line and suspended load. Load is load block, slings, and payload. So what is the approximate lead line stress? Is it 3950, 9445, approximately 7615, or 6932? Let's go ahead and enter our best option there. What's the lead line or line pull based on that system and that weight? So our answer, we're ready to put that up. Everybody got your boxes checked? Okay, and the approximate lead line stress is going to be 7615. Really what we'll do is take 45,687 divided by 6 parts a line, and we're going to punch in. I'll put that in for us here. And we've got 7615 rounded, and that is the lead line stress approximate for that application. And hopefully our line pull, allowable line pull on the crane is 8 or 9 or 10,000 pounds, and everything's working fine. So, but that's a good way to double check and see, am I above or below my allowable line pull for that crane? Excellent. Let's go to question 20. Everybody doing good? We're 2/3 of the way through. All right, let's take a look. We've got a cubic. We've got concrete. Reinforced concrete is about 150 pounds per cubic foot. If we had a block that measured 5 foot by 4 foot by 4 foot, what are the approximate cubic feet and what's the approximate weight? That's what we're looking for. Take a look. Some of you have smartphones or calculators. You can do a quick estimation. And so is the potential best solution, is it A, 20 cubic foot at 3,000 pounds, 64 cubic foot at 9,600 pounds, 80 cubic feet at 1,200 pounds, or 80 cubic foot at 12,000 pounds? We need to know what the weight is based on our information provided to us, because we've got to make sure we can handle the load. All right, we're about done here for this question. Let's put our answer up. Everybody got your box checked? So let's take a look. And the solution really is 80 cubic feet and 12,000 pounds. So we have 5 times 4 is 20, times another 4 is 80 cubic feet. And each one of those weighs 150 pounds per CF, cubic foot, and that equals about 12,000 pounds. Okay? So our solution then is 80 cubic feet at 12,000 would be our best choice there. Good job. I hope everybody ended up well on that question. We have to know our weights, whether the riggers help figure that out, the lift director helps provide it, or it's known information coming from some other source. We need to know what the weight is before we start moving the load. All right, great. Let's go to question 21. Here's here's a question about broken wire criteria for a mobile crane. So mobile crane, 6-stranded hoist rope. How many broken wires in a lay and how many broken wires in a strand in a lay? And to fill in those blanks, is it 2 and 4, 6 and 3, 7 and 4, 12 and 4? Which one is our best choice there? Mobile crane, 6-strand rope, in a lay length or in a strand in a lay length. And let's get our answers up here. Everybody's finished? Everybody's good? Okay, our solution for question 21 is 6 and 3. So we're looking at 6 broken wires, maximum in a length of lay, or removed for 3 in 1 strand and a length of lay. And you notice, if you remember I'll just put this up here, mobile crane at 6 and 3. Overhead crane, it's 12 and 4. The reason we actually allow more broken wires in a overhead crane, typically this rope will be potentially in the 6x36 construction family, and down here we may be in the 6x19 construction family. So 19 wires per strand for mobile cranes, or 26 wires per strand for mobile cranes. Overhead cranes typically have a lot more wires to start with, so 6 times 36, and then we have more wires to break, basically, and it's a little more indication that we've got a bigger population of wires in the overhead crane, and that's why we have a 12 and 4 versus a mobile crane 6 and 3. Your organization may decide, well, we're just going to play by one set of rules, and we're going to use 6 and 3 for everything, and that's just fine. And so that may be your corporate position, is just to stick with the 6 and 3, and that will serve for all cranes. You could even, if you want, you could even apply it for slings. But that's the most conservative number out there right now in the industry, and that applies to mobile crane hoist ropes and boom hoist ropes. All right, very good. Let's go to question 22. A BTHLD, below the hook lifting device, must display, and if any of you have been looking at the ASME B30.20, that's the below the hook lifting device standard. So what needs to be at a minimum displayed on a custom lifting device? A, name and address of the manufacturer, serial number and load weight, and the weight if over 100 pounds, and then all the above. So which one is our best solution? Which one is our best solution? A, B, C, or D? Couple more seconds. Excellent. Okay, we're going to put the answer up. Hope everybody's got theirs checked. And the answer for 22 is all the above. And really, typically, because most lifting devices weigh over 100 pounds, you'll generally find we're going to have the manufacturer identified, the serial number, rated load, and its tear weight. Because that spreader bar or lifting beam is going to weigh, let's just say it's going to weigh 852 pounds, that becomes rigging weight for us. So it's a substantial part, and it may be what pushes us over the limit for the lift capacity of the crane we're using it with. So we need to know how much does that bar weigh, and short of having a scale, fortunately, the guys on that committee have instructed all of us that when they get designed and get produced, they'd like to have that weight. If it's over 100 pounds, it becomes something significant enough to account for in the rigging. Even sometimes on our lift plans, we will, even if it's 84 pounds, we'll still put in the weight of the bar or spreader bar or lifting beam. So, but these are the 4 items that we need to make sure we address. And the pounds is the wild card there based on its actual weight. Very good. Okay, let's go to question 23. Wire rope on an overhead crane, and this is one of those standards that you may decide to go more than this, but the minimum for wire ropes on an overhead crane shall be secured to the drum with no less than how many full wraps of rope when the hook is in the extreme low position and the crane does not have a lower limit device. So on the drum, this may be a groove drum, And we need to make sure that when we have a dead end connection over here, we're going to start wrapping that rope up. How many wraps do we need on that drum minimum with the hook in the extreme low position? Is it 10, 5, 2, or 8? And this is minimum. You may decide to increase this based on your operation or your organization. Everybody got your box checked? Okay, let's put the answer up, and the answer is a minimum of 2 wraps. And part of that is you want to make sure that we take the strain. You may opt to put on 3. I know our friends in Alberta, I believe, have a minimum of 5 by that province. This was an ASME type question. So there may be states, cities, provinces, or countries that have a greater requirement. However, at a minimum, and part of the deal is we want to try to take some strain off of that dead end connection, so we're able to put in another wrap there. So we're able to reduce the direct load. That's the whole deal, is direct load to the drum infitting. You don't want live load. I say this, the maximum load. You want the wraps to be able to take some of that load and accept that from friction, and it works a bit like a capstan. So you want to try to minimize that load directly to that dead end connection right in here on that drum end, and not have it pulling all the time against it with direct load as equal to parts of line. So there is a purpose and a reasoning behind that. So okay, let's go 22 and 23 and 24. Question 24. A blank hook can be used in a chain sling to adjust the leg's length. So what kind of hook will accommodate or allow us to adjust the length of the sling leg? Is it a locking latch hook, a standard sling hook, a grab hook, or a foundry hook? Which one of those 4 will accommodate that adjustment process? Just a few more seconds. I think we can get our answers in there. Everybody get your SurveyMonkey box check there. All right, let's put the solution up on the screen, question 24, and that answer is a grab hook. And almost every chain sling assembly we have in our company, we have lots and lots of chain slings. We have some type of hook on the end down here, typically locking latch hooks, but we also order these slings with a set of grab hooks or such that they're incorporated into the master link. And so that we can shorten a leg at any time, we'll shorten this leg, we'll come up, go through, and we'll shorten that leg to that position, and we might have a longer one, so that at the end of the day, we can calculate the tension required. We've got a raft of leg there that's not being used, and rig into that connection for an offset center of gravity type load, and we can get that hook over the CG. So short leg one side, long leg the other side. Make sure that we understand we have to know the tension in each leg so we don't overload the slings, but the grab hook is designed to help shorten that leg up to accommodate to the center of gravity. Remember, we talked earlier about load weight. That's the first step, CG. Second step, rigging method is the third step. And rigging method will help ensure that we've got rigging with sufficient capacity to take care of sometimes this offset center of gravity issue, so we don't overload any of our rigging while we make the load move. Excellent. Okay, let's go forward. Let's go to question 25. Let's go, let me get the right one clicked here. Additional counterweight may be added to a mobile crane. Well, that sounds strange. If which of these conditions is met? You can add additional counterweight only if it is the only way the lift can be made, you're working in the stability area of the load chart, approved by the manufacturer, or your supervisor approves. Which one of those 4 is correct? A, if that's the only way you can make the lift, so put a big 12,000-pound compressor on the back of the counterweight, or you're working in the stability area of the load chart approved by the manufacturer, or D, your supervisor approves. So which one is our best solution answer there? Let's take a look. Everybody got your boxes checked? And the solution here is only if approved by the manufacturer. Adding weight to a crane is really dangerous. It can compromise the crane. It can buckle the superstructure floor, do bearing damage, all kinds of things can, and actually help overturn the crane backwards if we boom up. You got more weight on the back end than we anticipate, and more than the load chart was designed for, and all kinds of bad things can happen in a hurry. We don't want to do that. This is only with approval by the manufacturer. And if we think we have to add weight to a crane to make a lift, we probably got the wrong crane. We need to be getting a bigger crane, making something else happen. It isn't uncommon for pile driving and other similar applications where a generator may be added or compressor may be added to the back of a crane. But that is a direct phone call with serial number of the crane to the manufacturer saying, here's the boom link we want to put in, here's a counterweight existing, we want to add X at this point, and they may or may not give you permission. So, but you got to ask. We don't want to compromise the crane and have a wreck. All right, excellent. Let's go forward. Question 26, leveling of the load. Leveling of the load can be achieved using what? A bridle hitch, adjusting the tagline, adjusting the softeners, or a chain fall. Leveling of the load can be achieved by A, a bridle hitch, B, adjusting the taglines, C, adjusting the softeners, or D, a chain fall. Make sure we got our boxes checked in the Survey Monkey. Let's take a look. I'll put the answer up. Everybody ready? Okay, here we go. And the answer here is item D. A chain fall has the ability to intake and output different the length of the load chain, so that, and what we're really doing is, if the center of gravity is a bit offset, what we're really doing is, and I'll put a sling over here and up there. Here's our chain fall. It's coming down, and we're going to run that from the floor down here. What we're really doing when we take up or pay out on a chain fall is we're moving the crane's pick point, left or right in this case, over the center of gravity. So here's the thing. Don't get in the idea in our heads that we're moving the CG. We're not moving the center of gravity. The center of gravity basically is stationary. And we want to make sure that what we're doing is we're actually moving the crane hook in relationship to the CG. That's what we're really doing. That's basically a solid point, maybe in midair, but it's fixed, unless there's sand or fluid or something else moving in the load. But assuming that it's all solid and that it's all uniform, that there's no liquids or movable items, that CG is in its place. And what we're really doing is moving the crane hook to get over that center of gravity to get that load to level up. So our best option is a chain fall or some similar device. Excellent. Okay, we're just about done here. We just got a few more questions left. Let's go to 27. When examining a hook for spread or spreading, the what is measured? What are we measuring when we're trying to identify hook spread? Are we measuring the mousing length? Are we measuring the shank elongation? Are we measuring section thickness? Are we measuring throat dimension? So we're looking for hook spread, and to identify that, what do we measure? Mouse length, mousing length, shank elongation, section thickness, or throat dimension. So let's go to our solution here. Everybody got your boxes checked? Excellent. All right, we're going to be measuring throat dimension, and really probably an ugly hook dimension here, but we'll go up to that thrust bearing and our block and so on. And what we're really measuring is, and then put a flapper latch in there, we're really measuring this distance. That's throat opening or throat dimension. And if that hook is starting to spread, that dimension will increase. And that's what we're really accounting for. Okay? All right? And we know that, I don't want to answer that question right now, but I'll come back if we don't cover it later to give you the dimensions. Some of you know it, and some of you might not, but we'll see if we can get it covered. All right, excellent. Let's go to 28. To create low compression and grip. So there's two things we're trying to achieve here, compression and grip, while maintaining a high rate of capacity. So it's really three things. Which hitch should be used, or hitches? So we want to squeeze and grip and maintain a high rate of capacity. So which hitch should be used, or hitches? So it is a single wrap choker hitch, single wrap basket hitch, double wrap choker hitch, double wrap basket hitch. Okay? So to squeeze it, grip it, high capacity, single wrap choker, single wrap basket, double wrap choker, double wrap basket. Let's go to our solution. Everybody got your box checked there? All right, excellent. Let's do it. Based on that, those demands is a double wrap basket hitch. So we may have a bundle, a pipe bundle. We've got a whole bunch of pipes here, and they're all bundled out there. And so we really want to create the best. So we're going to come down with our sling. We'll double wrap once, twice, go back up, come around. We're going to double wrap once, twice, come back up. And so we get the double capacity based on the basket hitch, and two wraps help create that grip and compression. Okay? So we've won in both cases. That's about as good as you can get. Make sure that we're rigged over that CG and everything's cool there. So, okay, all right, excellent. Let's go to the next one. Mousing a hook is used to do what? Mousing a hook, that's an old industry term. And is it to secure the rigging to the load? Do we mouse a hook to secure the rigging to the load? Do we mouse a hook to secure the load slings in the hook? Do we mouse a hook, which is just wire tying across the throat, secure the hook to the wire rope, or secure the wire rope to the lifting device? So we'll just put that hook right up here, and that would be something like wire tying, old method here. We'll come back and wire tie that shut. So what is the purpose of mousing? Secure the rigging to the load, secure the load slings in the hook, secure the hook to the wire rope, which would be the hoist line, or secure the wire rope to the lifting device. All right, let's make sure and check our appropriate box, A, B, C, or D. And I'll put our solution up, and it is to help secure the load slings in the hook. And this really is, the best shot is when the slings are in an unloaded condition. We know that mousing or flapper latches, a lot of even locking pins don't totally assure that the rigging is going to stay in the hook if the slings are pushing against the gate or the latch. But mousing is a way to help try to restrain or keep the slings in the bowl of the hook should they get any kind of turn to them or readjustment in a slack condition and an unloaded condition. Okay. All right. Excellent. Let's go to the last one here. Let's take a look. All right. Two types of fabricated chain slings are this and that. There are two kinds of chain slings fabricated in the U.S., meaning they are used. There are two assembly methods that put the chain slings together. One on A, the option is welded and hand formed. B, mechanical, hand formed. C, machined and fused. Or D, welded, mechanical. there are two types of fabrication or assembly methods to put slings together, A, B, C, or D. Let's pick our best one that we think about is going to give us the best solution here. I'll put the answer up on the screen. Everybody ready? Okay, here we go. And the best answer for us is welded chain slings and mechanically assembled chain slings. So D is our answer for the fabrication of chain slings. I want to go back just for a second to that the hook question that we had, and let's see if we can pick that up. And that is hook spread. So back on 27, and this was the hook spread, and let's see, we got our answer here, so we get this. Okay, hook spread. And in the new ASME documents, B30.10, that's an ASME standard for hooks, that is not to, it is less than 5% throat opening, not to exceed 1/4 inch. So I need to look it up, but it's equal to or less than 5% throat opening, the 5% of the original measurement. So original's here, and now we're out to here. So not to exceed 5%, not to exceed 1/4 inch. Okay. All right. Excellent. So we have our last one was available there. Jonah, were there any questions that were typed in our box? I don't know if anybody had any time to, or are there any immediate questions that we can help resolve for this for the webinar?
Yeah, there is one. I'm going to get to that in just a second. I want to show everybody and I'm sorry I didn't touch on this in my introduction. I meant to. I know I went over a lot there, but it's important that you fill out these last two boxes, your name and your email address. This will be the email address I send your results to, and that way, like I mentioned before, you can cross-check your results once we post the presentation file on the archive page. So now that I did that and everybody saw how to do that, it's pretty self-explanatory. I'll pass it back to Mike, and I'll get you this question, Mike. It's regarding question 18 on the quiz, which is on slide 41.
All right.
So we had a question. I'm sorry, let me get it here. It was, does the kind of core in the wire rope lower the temperature that you can use for lifting? So specifically, does a fiber core lower that maximum temperature?
Yes, that's an excellent question. And the fiber core in a wire, I'll just put WRS up here for wire rope sling. The fiber core is limited to 180 degrees Fahrenheit. And if the temperature exceeds 180, we have to assure ourselves that we're going to switch over to an independent wire rope core to get that range that will go up to the 400 degrees Fahrenheit point. So there is a limit, absolutely, for fiber core slings, not to exceed 180. It literally will melt out and spill out from the inside to the out of the rope of the sling and lose the foundation of the sling. It will imbalance the strands and cause a much lower strength sling because it's imbalanced. So there absolutely is a difference. Thanks. That's an excellent question. And this has to do with independent wire rope core slings, standard IWRC, not the fiber core slings because they have that limit. Great question. Excellent question. Any other questions?
That's all we have for now.
All right.
Come in the next minute or so. I got to say, everybody who was logged in, they stayed on the whole time, so I hope that means everybody submitted their quiz. So thank you guys for paying attention, and I hope you picked up, I mean, at least a couple nuggets of information that maybe you were you didn't know about before or you weren't sure about. Hopefully this got you the answer you were looking for. But thanks everybody for participating and sticking with us with using the new format a little bit there.
Okay, Jonah, you might explain to them now what will happen with their surveys and how they can check their answers out against the original questions again.
Sure, and again, I hope everybody submitted it with your name, the email you wanted to receive your results at. I will send out individually, again, nobody's going to see your answers, but I'll send out your responses to you individually. And then you automatically get a link to this webinar recording. You don't have to watch it back through to get the correct answers. We will post a link to the presentation file that both Mike and I were working off of, and that'll have the right answers. So you'll have to cross-check those at that time. But yeah, Mike has it on his screen there. If you do have any questions or you're wondering about something specific, please contact me via email. I'll get to you as soon as I can. I'll find you the answer that you're looking for. So yeah, that's how we're going to do it.
All right. Thanks, everybody, for participating today. We look forward to seeing or having you with us on another webinar in the near future. We're going to have some terrific presenters, both in company and some guests throughout the balance of 2014. And we sure look forward to having you with us at those times. And let us know if we can help you in any way, whether it's training or consultation, look plan ideas or look plan reviews or anything like that. And hope everybody has a great summer. And so make it fun for the family and safe. And we look forward to visiting with you in the very near future. You guys take care, and we'll be talking to you soon.
Thanks, everyone.